right, here we go. The BLC has got a bunch of wristbands that say Brothers for Bo. We've been praying for Bo Branyan, and we want to continue to pray for him. So if you talk to your either homeroom captains in your advisory or your BLC rep, or just chat up Coach Ken and see how you guys can score you one of these sweet wristbands in solidarity and support for our brother Bo Branyan as he continues with his battle with cancer. I think that'd be a nice way for us to support him. That being said, Ryan, you see what I'm seeing now, and you guys see what I'm seeing. Let's talk about exponent rule number 5. We discussed yesterday about how we would have the product of two things raised to a power. We would add their exponents. We talked about the quotient of two things. We'd subtract their exponents. We talked about negative exponents as well. Okay. Now we're going to talk about what happens when, and Sebastian actually asked this question in class, I believe, what happens when I raise something to one power and then raise it to another power? Okay, in those cases, Joseph, we're going to multiply our exponents. And the mnemonic device that I have for this kind of thing is, well, what do you normally do when you see two things sitting next to each other like that? What normal operator is implied there? Yeah, multiplication. So it would be no surprise then when I see something like x to the 5 to the 3, those numbers are sitting right next to each other, separated by a parenthesis. So it's almost as though they're screaming out, multiply me, multiply me. So that, for example, would be x to the 15. Okay. Down here, example 9, this would be x to the what? X to the 6. Now, of course, we can still do the long, drawn-out approach. If you forget, I've been there, done that. Okay. If you forget, just take the slow road. What does it mean to cube something? It means to multiply it by itself thrice. So x squared cubed is x squared times itself thrice. X squared times x squared times x squared. Okay. Well, what's x squared? X times x. And how many x's do you guys see there? 6. So that's how if you forget your rule, that's how you can kind of derive it quickly. Now, the problem becomes, well, what the dump do I do if I've got variable exponents or if I've got, really big exponents? Well, just in the sidebar, just make up a simple example like this. Remind yourself of the rule and say, oh, yeah, I'm supposed to multiply those exponents. William? Mm-hmm. Mm-hmm. Great question. So if you didn't hear his question, we'll reiterate. So like let's say we had something like 16x squared. What's being squared there, Drake? The x is the only thing being squared there. Now, is that different, class, than 16x squared? What's being squared there? The whole shebang, the 16 and the x. Okay, so like this would be 256x squared, whereas the other one's just 16x squared. William, is that kind of what you were talking about? So now, yeah, you're absolutely right. Now this is an example of one of our exponent rules where it's the power of a product, where we said, if I've got a b to the n, that's a to the n, b to the n. In other words, we would apply this cube to both the 16 and the x squared. I don't know what 16 cubed is. I'll just have to leave that as 16 cubed. But what is x squared cubed? We just talked about that. X to the 6th. All right. And so you're absolutely right, William. You would apply that cube to the 16 and to the x squared. All right, Luke?
Why do they call it like squared when it's 3? One squared would be like 4 or like 2? Since like S.
When you say what you said again, I think you said something about the number 3. I didn't follow.
Why would it be squared if it's 3? Like why do you call it like 16 squared?
It isn't squared.
So okay, so like check this out. Look, this is x squared. This is x cubed, and this is x to the 4th. So the reason that when we say the word squared is because in Latin the word quadris means squared, and that idea of quadratic. Also, a square is in 2 dimensions, whereas a cube is in 3 dimensions.
That's why. Yeah, I meant cube.
That's all good. The reason that we call something cubic is because it's raised to the third. Like, what's the volume of a rectangular solid? Do y'all know how to find the volume of a rectangular solid? Length times width times height, right? So that's 3 dimensions. So like if this cube was x inches by x inches by x inches, his volume would be x cubed. Whereas if this square was x by x, his area would be x squared. Will Prum? Yeah, and that, does anybody know what a 4-dimensional analog of a 3-dimensional cube is called? If you've seen the Avengers, you know what it's called. A tesseract. Very good. A tesseract is, and I won't take our class time up right now, but it's a 4-dimensional analog of a 3-dimensional cube, of a cube that's passing through time. The 4th dimension being time. Imagine a cube passing through time. Again, I won't take time to do this, but just Google, information about the tesseract, and they've got some GIFs or GIFs. What do you call it? GIF? Jeff. Anywho, they've got some like little things that will show you that cube flowing through time. It's pretty trippy, but yeah. Other than that, I couldn't tell you much, Will. Yeah, exactly. Fifth dimension and all that stuff. Now there is stuff called string theory, and that gets into more theoretical physics, and that is not my forte at all. But there's string theory and then superstring theory, and they go on up into like 11 dimensions, and I don't. They've got weird names like quark and charm and I don't know what else. Sebastian.
Yeah, like an exponent that combines a bunch of different goals, what are you do that and be like?
So you're going to start to see examples like that. If you heard what Sebastian said, like an example that starts to pull in several of our exponent rules all together, that's where we're going. And so what we're going to do, like look at example 10 with me, you guys. Y'all jot that example down if you haven't already. What we're going to do is we're going to apply each of our exponent rules as they come about. Okay? Like, for example, on the macro level here, what am I doing? I'm squaring something. Now, that something is a product. So from one of our exponent rules, the power of a product, P-O-P, pop, we're going to apply the rule that says, okay, well, that's -5 squared. Here, let me zoom in a little bit so y'all can see better. That's -5 squared times x cubed squared times y squared times z squared, right? Because each of these individual factors over here are going to be exponentiated now to that second power. And then we just work them out. Quinn, hit me up with the first one. 25. Good. JT, the second one. X to the 6. Fabulous. Y squared, we don't have anything to do. Cannon, hit me up with the last one. Z to the 4th. Fabulous, you guys. And that's all we got to do. If you keep your head on straight and remember your exponent rules and practice them, for Pete's sake, that's why I gave you that big fat daddy homework assignment this dude, so we can practice using all these exponent rules. If you keep your head on straight and remind yourself, like -5 times -5, we lost the negative. Why is that? Because a pair of negatives goes away. Then you'll be fine. All right. Let's move on to our next example, and I'm gonna let you guys try this one all on your own. Actually, I'll let you try both of these. Can you guys see all that? Oh, yeah. I love it. Hey, I'll give you several minutes to work on this, and I'm going to call on some people. We got 8 problems here, so I'll try and call on 8 different guys, and let's see if we can run the table. Let's see if we can go 8 for 8. Okay. Be careful about example 12, part B. There's that negative exponent. Be careful about negative, or part D as well on example 12. We got a couple negative exponents there. Be mindful on example 11, part B. There's a little trick there. And then you got a couple negative exponents on part C and part D there of example 11 as well. So keep your head on a swivel here, fellas. Make sure you don't get tripped up. Pardon me just for a moment. All right, there we go. I'm so happy this Friday. You guys have no freaking idea. Oh my gosh.
It's a good Friday.
I didn't know.
Last Friday was Friday the 13th. Spooky. Although tomorrow I've got a full day planned, I'm still stoked that it's the weekend.
I got hard maybe a rest. Yeah. We do.
What are y'all barbecuing?
Wings.
Doing some wings. Y'all doing whole wings? Or you got them split or what?
I don't really know, but like you're supposed to make your own, or you can make your own sauce and have a sauce competition.
And we're bringing them rolls and stuff, or just gonna be.
Yeah, making that like mango habanero.
Good for you,
I'm
dude.
gonna make my dad's sauce. 'Cause he's from like 10, like the school ones. That's cheating, Wilson.
His sauce is the boss.
It's not cheating. It's just passing down things.
It was just our school.
How long does it take to smoke a wing?
Probably like
Not very.
Are y'all grilling or smoking?
We're grilling.
Smoking takes too long.
Smoking would take a while, but they those wings are usually pretty quick to cook in anyway.
it's 12 to 2, so.
Not so long.
12 to 2? Yeah, you're probably not smoking from 12 to 2 because it would take you 30 minutes to get the smoker going.
And it takes you like 6 hours.
Not really.
They probably started.
Maybe it's an hour and a half.
John Michael Posey was telling me.
If it was ribs.
Oh yeah, ribs take.
Yeah, rib steak.
Like a brisket.
Last night there was a fatality on I-40, and it took me 2 hours to get home. I mean, it was just completely jacked up. And so, oh, that's too easy. And so anyway, I was really, really hungry. And so I was like, I'm going to stop at One and Only and get some ribs. And I pulled up there and did not move for like 5 minutes. And there was only 3 or 4 cars in line. And so I was like, all right, screw this. I'm going back home. But it was,
You can tell Camden to stop drinking like 2-liter bottles of Coke. every
Oh
day.
my god,
Yes.
it's insane.
He drinks 2-liter bottles of Coke, and then he also like eats crystals every day. You like,
to each his own, man. To each his own.
you like, I'm worried about your
Heart
liver.
attack in like
Yeah.
2 years.
He got kidney stones, and he used to drink milkshakes, but now he switched to Coke because he got kidney stones.
Milkshakes don't daggone cause kidney stones.
Coke
I know,
causes
if you don't drink the right amount of water.
Hey, does anybody, this is a practice bonus question. Does anybody know the the medical term for kidney stones? As a math teacher, I find it quite interesting.
It's a rock. Kidney rock.
Renal calculus. Renal calculus. That's your OBQ, practice OBQ next time. Did I look that up? No. I have known that for many moons. All right, y'all ready to go, or y'all need a little bit more time? I think we're getting too chatty.
Are you going to Black Horse?
Yes, JB. Ask me in the comments if there was a good. I was like, what tournament would you skip if you had to skip tournament? Like, oh, Blackboard.
Luke, are you done?
Yes, sir.
Good. All right, let's get to work, fellas. Here we go. Example 11, part A. Luke, actually, I'll hit you up first, son. What do you got?
I got -9, M3, N3.
All right, very close. I like m cubed and n cubed. What's -3 times -3 times -3?
Oh, that was my bad. That's 27.
-27, because we got an odd number of negatives. All right, Colton, what'd you get for part B? One is the loneliest number that you'll ever see. Why one, Colton? Other than 0 itself. 0 to the 0 is
0.
undefined. Very good, Hogan. Colton, make a note that anything raised to the 0th power, other than 0, is equal to 1. I don't care if it's 5 to the 0, 11 to the 0, -42 million to the 0. Okay? If you've got something raised to the 0th power, other than 0, it equals what, class? 1. It is the loneliest number that you'll ever see. Question, Luke.
I thought, maybe I just misunderstood. When you said it was raised by 0, I thought you meant like don't change it, like it was multiplied by 1.
Nope.
Okay, I thought that's what you meant.
If you go back, we had in green our little pattern. I'll go way on back, right up there. There's where we were talking right there about it. And we were saying that, hey, like x to the third is 1 times x times x times x.
Oh, I know. So what I thought was because like x is just 1x, so I thought it was like it would always equal like what it was, you know?
Yeah, and I think there's no show. That's the identity property multiplication times them by 1. All right, but we now know that if we raise something to the 0th power. Okay, let's see here. Justin, what'd you get for part C? I like k to the -6. Okay, we got 6 to the -2 times k to the -6, just for implying that negative exponent. Is it good form, Nick Pacey, to leave negative exponents?
No, sir.
No, it's not. So what can I do with that?
But
Yeah.
I got 1.
There we go. That's perfect. Okay, so what we would do is if you wanted to apply the power of a product, as we did in our first step, that means raise the 6, that's the first factor, raise the 6 to the -2nd, and k cubed to the -2nd. I went ahead and did that second ahead. What's k to the k to the 3 to the -2? We multiply those two exponents, and we get k to the -6. And then we put both of those underneath the 1 because we had negative exponents in its bad form to leave something with a negative exponent, okay? An alternate way is to take care of the negative exponent first before you deal with any kind of exponentiation. So look at part D here, and William Bryan, what do I do from there? If I left the 5 alone, because he did not have a negative exponent, yet I moved the x down to the bottom and changed his negative exponent to a positive exponent, now how do I apply my squares? Perfect, son. Well done. 25 because it's 5 squared. X to the 6 because it's x cubed squared. Okay. Savvy, any questions on 11? Calderon?
For 11D, you could have just put 1 over 25x to the 6.
No, that's a good question. The 5 does not have a negative exponent. So I would leave the 5 alone. So like if we had 5x to the -3rd, forget the square, just 5x to the -3rd, right? That's going to be 5 over x to the +3rd. The only thing I move, that's like saying if Teddy and Betsy, Teddy's got the bad attitude, Betsy does not, I'm going to put Teddy to work. I'm going to move Teddy around. I used that example yesterday, right? Okay, so like you only moving the factor that's got the negative exponent. And then if you're squaring after the fact, then you can apply the square as needed. You get your 25 and you got your x to the 6. Does that make sense, Santiago? All right, great question, you guys. Part D here, example 12. Let's see if cash money. You got part A for me? What do we get? All right, let's see if we can apply. We've got the power of a quotient. That's okay, Cash. I want you to raise the top to the 4th power and the bottom to the 4th power. What's b to the 4th? Just b to the 4th. And then how about 3 to the 4th? You got that one memorized? What's 3 times 3? Times 3? Times 3. That a boy. An easier way, by the way, it would be to split it up 2 and 2. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. All right, so in other words, we just apply that 4th power to the top and to the bottom, okay? All right, let's see here. JT, what did we say? I'm going to ask you a very specific question. What did we say yesterday you could do to a fraction that is raised to a negative exponent? Flip it. Oh, yeah, flip it real good, boys. We're going to flip that fraction, j over k, and I am not jk, because you can change the exponent. See what I did there, Joseph? You can change the exponent now to a positive 3. And Alpern, what else? J cubed over k cubed. Yeah, that's a completely different way of working it, but that's totally fine too. So like, in other words, if we applied that negative 3 to the k, and we applied that negative 3 to the j, and then we said, oh, you know what? K, move downstairs. J, move upstairs. And then you get your answer that way too. Different strokes for different folks. That's what we're going to learn here, fellas, is that you might work with these exponent rules one direction. I might go another direction, and we get to the same answer there. Luke.
I've explained this already, but why can't we keep negative exponents?
Okay, so it's like in elementary school. You remember when your teacher taught you not to write your fraction like that? What's wrong with that?
Oh, no,
Yeah. And so technically, aren't those the same numerical value? Isn't 3/6 the same thing as 1/2, numerically speaking? Yeah, sure. But one of them is considered acceptable. One of them is considered not acceptable. So it's a matter of form, okay? Now, truth be told, when you guys get into calculus, it'll be advantageous for you to sometimes leave a negative exponent in your problem. But in algebra, the reason that we consider it is really so that we can teach you how to manipulate, how to change. You need to learn how to be versatile and have both. So we say, you know what, don't leave negative exponents, therefore forcing the students to say, all right, I'm going to learn how to handle negative exponents forwards and backwards. Okay. Let's see here. Part C, William Kreitz, you got this one?
I got 8 x to the 3rd, y to the 6th over.
Fabulous. That's a lot going on there, isn't it? Now, what we could do if we slow plate it, check this out. I'll move this down. That's our final answer, so William's absolutely correct. But check this out. If we wanted to slow play it, we could say, hey, let's cube and let's cube the bottom. Okay, and if I cube the top, that's 2 cubed times x cubed times y squared cubed. 2 cubed is 8. X cubed is x cubed. And then look at that right there. That's power of a power. What do we do with those exponents? Multiply. 2 times 3 is 6. And that's how we got y to the 6th. And then, of course, z to the 3rd is just z to the 3rd. Sebastian, you see what you did wrong?
Yeah.
All right, Nick, pace your question.
I don't see what I did wrong. My answer was 8 x to the 3rd, y to the 6th over 8.
Over 8.
You thought your z was a 2.
Yeah, you wrote there, boy, JT. You thought that z was a 2.
Wouldn't that end up equaling x to the 3rd, y to the 6th?
Yeah, if the top and bottom both had an 8 on it, you would cancel those 8s. And BT dubs, y'all notice how I write my z's? Why do you think I do that? Yeah, because that looks like a 2 to me, or a z. I don't know. So you'll figure out with y'all's handwriting. Sometimes I had a kid yesterday that was writing his 3s. I can't remember who it was. I think it was one of my seniors. He's writing his 3s and they look like e's. And I'm like, okay, I don't know how to handle that, but.
You got your 9. Your 9 is like crooked.
Hey, don't make fun of my 9. My 9 is straight.
Write a 9.
You write a 9.
All right, I'll write my 9. Look.
I suppose you like doing that. You make a little circle with a stick on it. How cute.
How do you hear 8? Oh, you did the weird way.
Dadgummit, what do you mean I do it the weird way? Don't tell me you make a snowman. Do you want to build a snowman? No.
No, he did the other way.
What do you mean that?
I make a letter S. I make a letter S and then come back up that way.
Make it act like it's low.
Yeah.
Make it act like it's
How would I do it back? Oh, that feels weird.
Yeah.
That feels very weird.
No, it's not.
Ooh.
Wait, what did you do?
Instead of making an S, I made a backwards S and then finish it with the S. All right, last one, and we got a Kahoot we got to play. I don't know if we're gonna have time for our Kahoot. Let's see here. Who's got this last? Ashton, I hadn't called on you yet. Ashton, what you got on this last one? This one's a toughie. Hey, we are being rude if we're not listening. Ashton, say it again. I don't think it's correct, but say it again. So I like Q to the 4th down low. All right. He's not negative, so he's going to stay down the bottom. Okay, so that's one fix. P to the what? Good. So P to the -3rd to the 2nd would be P to the -6, so we can move him down to the bottom. Or if at the very beginning we moved him down to the bottom, right? Before we applied that exponent of 2, we got P cubed down at the bottom, so it's going to be P to the 6th. And actually, I like putting things in alphabetical order, so I'm going to put P to the 6th down at the bottom. And then what about the numerator now? What should I have left? I'm asking Ashton, Dadgummit, William, your turn was last example. Ashton, what do you think? 16, that a boy. All right. That being said, we're going to get out our laptops, and we're going to have a real quick 10-minute Kahoot. We're going to have to fly through this.
I got really worried you're about to say quiz.
We might not get through all of our questions. There's 27 of them. But we'll go as far as we can go. Jacob, what's up? Nah, these all should be able to do in your head, I think. I think these will be doable in your heads. In my head, in my head, zombie, zombie, zombie. Anybody get that Office reference? What?
I just want to show you a revolutionary way to make an 8. Like
that.
That's exactly the same thing I was doing.
it's not.
Oh my goodness.
You were doing it the weird way. This is the simple way.
Get out of here with your revolutionary 8. What's up? It hadn't come up yet. It's still loading. I don't know why it's taking loading so long.
Yeah.
Hey, he did. He had it like crossed in the middle, didn't he?
He didn't look complicated.
Paisley, yours is like mine. Here's mine. All right. And yours is like that.
I start the other way, and the other way is like.
Oh, no wonder it took so long to load. They got this cute little classroom background. Kahoot thinks they're being all awesome, whatnot, like quiz is. Kahoot's got live music, dude. I saw a Kahoot rap yesterday. It was like number 9 trending on YouTube. Y'all see that? There's a famous YouTuber that makes these videos, and he made a Kahoot rap video. What, Sebastian? All right, I'm starting in 5, 4, 3, 2. Who's talking? Oh, the Mr. 8 guy. Uh-huh. Simplify. These are gonna go quick. You gotta be bang, bang, bang. Quick, quick, quick.
Wait, did I?
Yes.
I got the next one.
What the heck is this?
Oh. I got
Hanging out.
Wait, no, it's not. Oh, yeah, I'm on the. Yes, I'm second. Drake is highest climber. It's all those.
We're rolling, baby. We're rolling.
Oh, crap, I was counting them all.
Oh, bro, I was calculating that.
Were you too fast? Classroom superpowers? Really?
Mr. Morgan,
Yes, Ryan.
my Kahoot's literally lagging.
Guys, I can't hear Ryan. Get quiet, please.
My Kahoot's lagging so bad right now.
Oh, you got a big lag on your end?
Yes, sir.
I got you. Sorry, dude. All right, score report. Who's in second place? All right, Jack Sebastian Santiago. Okay, okay. Hey, between first and fifth place, it looks like less than 100 points. It's a pretty tight race. Pretty tight race. They're going to get more difficult, so. Why is this guy only giving 3 answers? That's what I want to know. Where's my fourth answer at? Dude, who hadn't answered yet? You multiply, you don't add. You multiply, you don't add. Oh! Hudson climbing up to that top spot. Oh. Oh. That boy Quinn. Quinny P.
It got confused because
Oh. Welcome to the leaderboard, Wilson. Oh, my bad.
I'm coming for you. What is
Is that me, Aaron? He's up on one. Blue.
Dude, let's go. What's going on here? There we go. All right, all right. Oh. 16-point differential between first and second.
I'm coming up at 2,000 point difference.
I noticed my 2 back row bandits are up top spots. Y'all doing some screen watching? Is that what that's going on?
How would you do screen watching? Is it we screen watch?
You're looking at what people click. That's what I'm. I'm just busting y'all's chops. I'm just busting y'all's chops. There he goes. There he goes. That lead spread a little bit. He's got like a 30-point lead now.
I'm literally right for these. Oh my god. Yeah.
Probably cancel out.
Oh, that's not bad. That's not bad.
All right, we're good. We're good.
Oh, get it, go
It's red. Oh,
Pick green, pick green. All right, no change there. We got time for about 4 more, maybe 5 more. Do, 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 do. Do, 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 do. Did y'all both miss it? Did y'all both miss it? Oh. 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 Off the board. There it goes. Holy moly. Coming in like a dark horse. Holy cow.
No. No, my God.
Get a little tougher now, huh? There's Stovall. Welcome to the party, baby. Three cubed is 27, not 9. Quinn Page is on fire.
Why do we have to do actual math?
There's 2 answers.
That's the math.
I know, I didn't get it.
We got 2 minutes. Down a 2-minute drill here.
For 10 questions.
Let's go. I made the leaderboard.
Why is it
Wait, what?
They kept me negative X.
Oh, okay. Oh, I see now. Shoot, dude. For some reason, I thought the last X was
What? Let's go!
Hogan up top. Attaboy. We got, hey, be nice. We got 2 questions left. 2 questions left. The top 5 get a bonus point, by the way.
Okay, I just.
I would have cheated if you told me that.
Dude, I can't read.
Not funny.
I just got.
Oh my god.
I'm really like.
I literally can't read.
Oh my. Dude, they're like,
I
they're
guess.
pulling some tricks.
Yeah,
You're like, I'm just right.
I'm coming home.
Last question.
I'm missing me home.
Last question. Don't miss it. Don't miss it. Whoa. What wizardry is this?
Black magic, that's what it is.
You got 15 seconds.
I don't like this.
5, 4, 3, 2.
Yes!
All right, live Jesus in our hearts. Y'all have a great day, fellas. Thank you so much. Great work. Great work today. Be nice. Wilson and Jackson. Quinn. Ogan. Hey, what Will was that? Will Perone? All right. Y'all get on out of here, boys. Thank you. Library. Yep. You might have to sweet talk somebody.